In part 7, we're going to briefly talk about how to name hydrated ionic compounds, but we're mostly going to focus on naming ionic and covalent compounds side by side, which can be tricky as the rules are sort of opposite. So there's one more group of compounds that we should talk about here. Hydrates are generally ionic compounds, but they contain water molecules in the crystal structure. So when we have these kind of charges stacked on charges, in between those charges we're going to have individual water molecules, which kind of hold the structure together. So for example, store-bought Epsom salt, right, that you just buy and people put Epsom salts into their bath, it's a magnesium sulfate salt, but it's got 7 water molecules in that crystal for every magnesium and for every sulfate. COCl2 6H2O is cobalt 2 chloride. Again, cobalt is a transition metal, and so that is a hexahydrate. So go ahead and try to name this following compound here, and then I'll show you a picture of it. So this is copper 2 sulfate pentahydrate. This is a very, very crystalline structure. It forms nice bright blue, like diamond-shaped structures. And if we look at this model on the left, each copper is essentially surrounded by 3 water molecules, and then it also has a water molecule above and below it as well to get us 5. And you can see they're evenly spread out, and it's part of what gives this structure a nice crystalline appearance.
Now, where this gets really tricky is that on this test, I'm going to switch back and forth between molecular compounds and ionic compounds, and I expect you to know which one is which. The easiest way to tell is that molecular compounds do not contain metals. Okay, the ionic compounds do. And that's the biggest difference. Now, the naming systems for these are completely different. You have to keep track of that binary molecules are molecules. They're what you think of as molecules. And as such, we are going to describe them with prefixes. What does the total formula look like? Carbon dioxide, 1 carbon, 2 oxygens. Since ionic compounds have trillions and trillions and trillions of atoms stacked on top of each other, we don't use any of those prefixes. We don't count the numbers of atoms at all. We figure out what is the charges that need to stabilize. Now, this is even uglier when you see those transition metals, because then they need to get a Roman numeral. Okay, but just think, things like sodium chloride, lithium chloride, LiCl, sodium oxide, Na2O. All of those things have a metal at the beginning of the formula, and so they use the no prefixes system.
Now, when it comes to naming compounds on the homework, a quiz, or a test, I typically break this up in steps. The first thing I need to figure out is if this complex is molecular or ionic. Once I know which category it fits in, I can more accurately determine the name. So think about each of these compounds first. I'm going to go through that in a few seconds, and then afterwards, I'll talk about how to name these things. So first, S2Cl2 is a compound made up of nonmetals, so it has to be a molecule or a covalent compound. Next, we have nickel paired with nitrogen. Nickel is a transition metal, so not only is it going to get an ionic name, but I'm going to have to figure out the Roman numeral associated with it. And finally, Al2O3, aluminum is a metal, but it's not a transition metal. It's a +3. So anyway, this is going to be ionic, so I will not use a Roman numeral in the final name. So with the first one, I'm going to use the prefixes here. So this will be disulfur dichloride. The second one, I need to use the Roman numeral, so I've got to figure out what that is. I've got 2 nitride ions. Those are both -3. I've got 3 nickel ions. Therefore, each nickel must be +2. Therefore, this is going to be called nickel 2 nitride. And finally, Al2O3 is just a regular ionic compound. We're not going to label the ionic charges because it only ever has one. So this is just aluminum oxide. Let's do the same thing here. Determine the type of each compound and then name it accordingly. Li2SO4, lithium paired with a polyatomic ion, so that has to be ionic. P4O10, all nonmetals, that's molecular. Now we have copper tied to the phosphate ion. Well, copper is a transition metal, so it's got to be ionic. And then Br2 is an element, so it's not going to use either of these systems. So watch out for that. That may show up in the homework or the exams if I can find good examples. Well, the first one is just a regular ionic compound, so it's just lithium sulfate. The second one is molecular, so I'm going to use the prefixes tetraphosphorus, deca, or decoxide. Copper, we need a transition metal. Now, technically, you don't need brackets for the phosphate here. I was just doing it to make it a little bit more obvious. Normally, you wouldn't see those. But since we have 3 copper ions paired with the phosphate, this would be a copper 1 phosphate compound. And lastly, Br2 is just an element, so no prefixes. We just call it bromine. Let's try this in the opposite direction. Based on the name, I would identify the type of compound it is and then determine the formula. So first of all, we have a Roman numeral. That should indicate right away we have a transition metal, and that's an ionic charge. That Roman numeral of 4 telling us we have a chromium +4 ion. Since it's paired with chlorides, this is just going to be CrCl4. Phosphorus pentaiodide. These are both nonmetals, but because we have the prefixes here, that makes this a little easier. It's just 1 phosphorus and 5 iodides. Finally, we have aluminum carbonate hexahydrate. And this can throw people off because they see the prefixes. Again, aluminum is a metal. This is an ionic complex. In this case, the prefix is just indicating that we have 6 waters. Now, to get equal and opposite positive and negative charge in the salt itself, we're going to need 2 aluminums, that gives us +6, and 3 carbonates, that gives us -6, for the formula Al2 in brackets CO3 3, and tied to 6 molecules of water.